In this lecture, we take a look at 2D curves. As many geometric operations involve curves, we start with basic two-dimensional curves. And for this, we will just use the top viewport. So we double-click it, so we see it at maximum size. Curves can be created from one of the tools at the left side. And let's simply start with straight polyline. Polyline is a line which consists of connected linear segments. So we click, and click a few times. We can press enter to cancel the command. We can also press the select button again to select the whole curve and then press delete to remove the curve. Now, if you want to have a more accurate positioning, we can of course use the grid snap. If you right click it, you can set the settings for the grid. And in this case, the grid has minor grid lines every 1 meter. So that way we can be assured that we have a very exact positioning. And we see that in total we have about 50 lines every meter and then split in 10 segments. Okay, so while clicking on a grid, you see that we are drawing in whole meters. We can of course also write down the exact coordinates, just as in a regular CAD application. We can work with coordinates, and if we just type 0, 0, then we get the origin. And now we can create other coordinates just by typing them in. For instance, 6 units to the right and 4 units in the y direction. It also works with relative coordinates, and relative coordinates are just like in other CAD applications, measured from the current point. We can type the R for relative, say 4 units to the right and no units to the up direction, which gives a horizontal line of 4 meters long. Or we can use the same symbol as in AutoCAD, the @ sign. Let's say 2 units to the X direction and 2 units in the Y direction. Gives you another clean position. Of course, using the grid snap, if you work in whole units, is often easier. Then you can work very intuitively. And we can also use the object snaps. And object snaps allow you to define certain positions if we enable them, like perpendicular directions, intersections, center of objects, midpoints, and many of the other points that we can usually find. Just type enter to close and we start a new polyline, and we can start from the mid of another line in an orthogonal direction if we can even activate orthogonal. Let's say for relative 4 units with an angle of 90 degrees. It's also possible, very similar to AutoCAD or other CAD applications. Or we can even use the smart tracking, which gives you the option of hovering your mouse over a point, which gives you an easy way to define exact positions without knowing the exact coordinates. So Rhino is first and foremost a CAD application. It's possible to make very accurate drawings. Now, for just regular line segments, just like polylines of some of the other options, we can also look at the curves. And the curves are NURBS curves. And NURBS is the acronym for Non-Uniform Rational Bezier Splines, which is a whole mouthful. But it's a mathematical way to describe a complex freeform curve with a minimum input that is required. Without reciting the whole history of the development of Bezier splines and NURBS curves, it suffices to say that you define a point using control points. So we start a curve, and let's activate our grid snap again, and we just click a few points. And from the second point we click, we see that the curve is not crossing through our control points, but the control points are steering the way the curve is folding. Enter. So this very complex if you have to trace it, is completely defined with just a few control points. And we can visualize these points with the option points on, and we see these are the exact points. So these 6 points are sufficient to define this complete freeform curve. And that is one of the biggest strengths in the methods of using NURBS, and Rhino is focusing on NURBS primarily. You define complex curves with a small amount of control points. And you can still edit the control points by clicking on the control points and dragging them up or down. You see that these curves actually attract the control points attract the curve, which makes it also quite intuitive way to refocus, to trim, to tweak the shape without having to control every single point on this particular curve. I can right click to turn these control points back off. So that is a control point curve. We have a few variations. An interesting one is the interpolate points, which is very similar to a control point curve. Let's move a bit to the side. But in this case, we enforce our curve to pass through the control points. So at first sight, it seems very easy, but if we activate our control points, we see that Rhino does the hard work for us and it calculates the real control points, which are not the points we clicked, which are on a different position. So these are the actual control points controlling the curve, but while drawing, it makes it a bit more convenient by allowing us to define the points through which we have to move. Okay, there are a few more options that we can use to further tweak our curves. And these can be found underneath this palette of curve tools. We can see that the curve tools are also available in one of the tabs above, so that is also easy to use. So suppose we have a particular curve already created. Let's turn it off. So if we activate the curve tools, we see that we have a more dedicated set of tools in the tab in the panel above and in the panel to the left. For instance, it is possible for us to further refine our curve by either closing it, so connecting the last point to the first point, which in this case is a bit silly operation, so we can undo it. After we drawn this curve, we can still modify it. And instead of just moving some of the control points around, it is possible to also insert new control points, remove existing ones, or insert a knot, or remove a knot. And a knot is a point onto the curve, which we can insert. For instance, we can click a point somewhere here, onto the curve. The curve itself does not change in shape, but we have an additional point to control the curve. And we have to press Enter to confirm the modification of the curve. And if we now activate our control points, you see that a new point has been created. And in this case, the previous points stay at their same position. One of the things you need to understand in the modification of these curves is that you tweak or you adjust the shape of the curve by changing control points. And the influence of a control point diminishes the further you go on the curve. For instance, if I move this midpoint, you see up to a certain position, and in extreme cases it can extend quite a bit, the curve is changing, but the start and the end of the curve are not changing at all. And that is a way to control and to tweak a particular shape and still remaining in control and being able to do this in a more intuitive, designerly way, which really fits for an architectural designer. So you can start shaping and tweaking and pulling the control points, knowing that the curve itself, you have complete control over it. You can also look at the removal of a control point. For instance, this control point, let's point on the curve to remove control point. Let's remove the grid snap, so it's easier to click on it. And then you see, because of the removal of the control point, the curve itself does change its shape a bit.